Hi, today we're looking at Functional Skills Maths Entry Level 2. We've got the Pearson Edexcel exam board. We're looking at past paper set 4 and we're going to start with a non-calculator section. Question 1. Marius is a builder. He works out how many bags of sand and cement he needs. Complete the calculation. 42 plus 19 equals. But what I'm going to do is I'm going to look at this as being tens and units. Tens and units. And I'm going to add the tens together first. So the 4 is going to be 40 and the 1 is going to be 10. So 40 plus 10 was 0 and 0 is 0. 4 plus 1 is 5. So we've got 50 from the tens. So this is our tens. And over here, we're going to have our units. Well, we've got 2 units and 9 units. Now, it's always easiest to start with a bigger number. So we take number 9 and we're going to add 2 more on. So starting from 9, it's going to be 10, 11. Okay, so we go to a total of 50 and 11. We now need to add those 2 together. So we want 50 plus 11. Now we can write these in a column. This is a column method. And we can say 0 plus 1 is 1. 5 plus 1 more is 6. So we've got a total of 61. And we can write that down here. If you're comfortable doing 42 plus 19 as a column straight away, that's fine. But this is a slightly simpler approach by looking at the tens first and the units and then putting them all together. Okay, question 2. Marius buys 12 pieces of wood. Each piece of wood costs £7. What is the total cost of the pieces of wood? So there's £7 each and we've got 12 of them. So we're saying 7 times 12. Or you might think of it as 12 times 7. Doesn't matter which way round you do it. If we want to work this one out, we could use a column method for this, but instead what we can do is we can split this up into tens and units. So we can think 7 times 12, or 12 sevens. Well, actually, if we think of the 12 as being 10 plus 2. So we can say, well, instead of 7 times 12, we can think of it as, I'm going to flip it around the other way and say, well, it's like 10 lots of 7, and then another 2 lots of 7. And we're adding these 2 together. Well, if you want 10 times something, you just add a 0 on the end. So 10 times 7 would just be 70. And 2 times 7, well, 2 times 7 is basically 7 plus 7. So start with 7, and we'll count on another 7. In fact, I'm going to write this here. So 2 times 7, we think of that as 7 plus 7. So start with 7, and then we'll have 8, 9, 10, 11, 12, 13, 14. So we've got 70 plus 14. So 0 plus 4 is just 4. 7 plus 1 more takes us up to 8. So we get a total of 84. And we can write that down here. And they've already put the pound sign. £84. Question 3. Marius has 72 nails to fix pieces of wood. Marius uses 8 nails to fix each piece of wood. How many pieces of wood can he fix? So we want to know how many 8s go into the 72. Or in other words, 72 divided by 8. So we can think of this in a couple of different ways. If you're good with your 8 times table, we can start with 8 and keep going until we get up to 72. So we could say 8, 16, 24, 32, 40, 48, 56, 64, 72. That's 9 times. Now, if you're not as comfortable with your times tables yet, we then definitely do some practice with them. But you could think of it a different way. You could think, how can we get close to 72 using something I know about the 8 times table? Well, you can think, well, what about 10 eighths? Well, 10 times 8 would be 80. And then how can we get, well, 80 is quite close to 72. Well, what about if we count back from 80 to 72? So it'd be 79, 78, 77, 76, 75, 74, 73, 72. So it's 8 less. So in other words, we're taking 1 off. So if 10 eighths are 80, if we have 1 fewer eighths, only 9 eighths, we saw that that was getting us to 72. So our answer must be the 9. So this is an alternative way of doing it. This is much nicer if you can do your time, if you know some of your times tables, or even if you don't know 8 times 9 is 72, maybe you can get part of the way there. So if you know 5 eighths of 40, for example, you can then count on 8 and another 8 and see how many times you need to count on 8 until you get up to 72. Question 4. Marius puts a new flat roof on a building. The temperature needs to be 21 degrees Celsius to work on the roof. Marius looks at the temperature. We've got 17 degrees Celsius. He says the temperature needs to be 6 degrees warmer. Is Marius correct? Show why you think this. Right. So it's 21 degrees. Or it needs to be 21 degrees. It's actually 17. He says it needs to be 6 degrees warmer. So we're trying to work out the difference between these two temperatures. And you can do that in 2 ways. You can start at 21 and count back to 17. Or we can just start at 17 and count up to 21. So if we start at 17, it'd be 18, 19, 20, 21. So we need to add an extra 4 degrees to get up to 21. He says the temperature needs to be 6 degrees warmer. Is Marius correct? Well, no, we've just worked out it's only 4 degrees, so we can say no. 4 degrees warmer. In fact, we can put that down here and tick the no box. Now let's have a look at the calculator section. Marius is a builder. He has a calendar to show his busy days. Okay, so we've got Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and we've got the weeks down here. And some are greyed out and some are white. We've got the key, which is really useful because that's telling us that all these greyed out ones are his busy days. Okay. Marius says he has 35 busy days on his calendar. Is Marius correct? Show why you think this. Okay. So if these are all the busy days, we just need to count them. So we can actually write the numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Now I tried to do it in a sort of methodical order. If I realised I'd missed one out, so I'd go back afterwards, check that they've all got a number on. It doesn't matter which order I do them, as long as I keep going up by 1 until I've done all of the grade square rectangles. So we've got 31 of them. He says he has 35 busy days on his calendar. Is Marius correct? No. And we can put there are 31. And I'll tick down there. Question 2. Marius needs to hire a digger. And we've got a few different diggers there on the table. Let's move this up. Okay, we've got digger A, B, C, D, E and F. We've got how wide they are, their width in centimetres, and whether they're available at weekends or not. Yes or no. Okay, so we've got Marius needs a digger less than 81 centimetres in width. He needs a digger that is available at the weekend. Which digger will Marius hire? So I'm actually going to go with the weekend bit first because this is a yes or no answer. So it needs to be available at the weekend. Is it available? Yes. So it could be that one. No. So it can't be that one. Could be this. No. So it can't be that one. Could be this one. No. So we've ruled 3 of them out already. Now it needs to be less than 81 centimetres. 82, that's more than 81. So it can't be that. 99, that's more than 81 as well. We've got one left, 75, which is less than 81. So Marius will hire digger E. Question 3. Marius needs to move the digger backwards. Which position will Marius move the digger to? Okay, we've got 4 different positions here. He wants to move it backwards. Well, this is going to be the front of the digger. It's facing that way. But he wants to move it backwards, which is going to be the opposite direction. So it's going to be D. This would be forwards, this would be to the left, and this would be to the right. Question 4. Marius works out how many building blocks he needs. We've got 11 something 10 equals 110. What is the missing symbol? And we've got 1, 2, 3, 4 different options. Well, we can just try it. We can use our calculator. So we can try, what about plus? Well, 11 plus 10 is 21. That's no good. Can't be that one. Now, if you can see with some of these straight away, then great. You don't have to use your calculator, but you've got this here to check. So, for example, 11, if it's minus 10, well, I know 10's just 1 fewer than 11. So I think that that's going to leave me with an answer of 1. Minus 10. Yep, it's 1, so it's definitely not 110, so it can't be that symbol. What about times? 11 times 10? Yes. That's the right answer. But let's just check. What about if it had been 11 divided by 10? 1.1. That's definitely not equal to 110. So we've found the answer and we've checked it as well. Question 5. Marius buys a pack of blocks. Marius buys the pack with the most blocks. Which pack does Marius buy? Okay, so we want the most blocks, so we want the biggest number. Well, let's start with the first one, 54, and let's see if the next one's bigger or smaller. So 54, 72, yes, 72, it's in the 7 tens, it's bigger than 54. So 72. Is 60 bigger than 72? No, 60 is smaller than 72, so it's not that one. What about 84? 84, 80, or 80 is bigger than 7, so 80 is bigger than 70. So 84 blocks is the biggest so far. 64, no, 64 is less than 84. And 48 is less than 84. So it must be that one. Question 6. This is the shape of a block. What is the name of this shape? So we can see it's a 3-dimensional shape because we've got height, width and depth as well there. So we've got to think, what shapes do we know? Well, we know we've got a cube. That's a 3-dimensional shape, but with a cube, all of the faces are squares. And we've got some rectangles here. So this one is a cuboid. Still got 6 faces, but not all of them are squares. Question 7. The chart shows the costs of different packs of blocks. And we've got packs, we've got pack A, B, C and D, and we've got the costs here and the bars to show us what these costs are. And the question is, how much cheaper is pack D than pack B? So we're only interested in D and B. Well, let's start with D. So let's go from the top of this bar and read across to here. So how much? Well, if this is £120, 125, so this looks like it's going up by 1 each time. Let's check. 121, 122, 123, 124, 125. Yeah. So we said this was £123. In fact, I'm going to write that on here. And what about for pack B? So use my ruler to read across. So if this is 130, that'd be 131, 132. Now, how much cheaper is D or pack D than pack B? So we need to work out the difference. So we take the most expensive one, 132, and subtract the cheaper one, which is 123. And again, we can use our calculator. And we get £9, which we can put in here. They've given us the units, but it's good to be thinking, well, what units would I be putting in? And then you can make sure that it's there. Question 8. Marius needs to meet a customer before 1:45. Which clock shows the latest time he can meet the customer? Right, so it needs to be before 1:45. Well, what's this time? Well, look at the hour hand, the shorter hand. It's after 12, so it must be 12 something. And remember, each of these are 5 minutes. Or you can look at it and say, well, it's pointing to the 6. I know that's half past. And I know that there's 30 minutes in half an hour. So that's 12:30. Or you could say, well, it's 1, 2, 3, 4, 5, 6 sections. 6 sections are 5 minutes each. 6 times 5 is 30. Okay, so we've got, this is 12:30. What time have we got here? Well, the hour hand is after the 1, so that's no good, because he needs to meet a customer before 1:45. Okay, this is after 1 o'clock, so I'm not even going to work out what time that is, because I know that's going to be too late. What about this one down here? Well, the hour hand is before 1. It's 11 something, because that's the last hour that happened. And again, we're on the half hour, so we know it must be 11:30. And if we look at this one here, the hour hand is just after the 12, so it's going to be 12 something. And it's 5, 10, 15, so 3 sections, so 3 lots of 5. So that's 12:15. Now what they actually asked us was which clock shows the latest time he can meet the customer, and he needs to meet a customer before 1:45. Well, 1:45, if you think of that on a clock, that would be, well, the last hour that it's passed would be 12, and 1:45, well, let's draw a clock here. We would have the hour hand pointing here before the 1, and 1:45 would be over here, which we can see would be pointing to the 9. So if we want to know how many minutes past 12 it is, we want 9 lots of 5, which is 45, so 12:45. So the time needs to be before 12:45, but we want the latest time. So the one that's closest to 12:45, but not after it. So that's why we ruled this one out. So we've got 12:30. We've got 11:30. Well, 11:30 is before 12:30, so that's not going to be the latest. And 12:15, well, again, that's before 12:30. So the latest one, or the one closest to 12:45 without going past it, must be 12:30. Question 9. Marius needs to buy a ladder. We've got ladder A for £80 or ladder B for £57. How much cheaper is ladder B than ladder A? Use the correct symbol for money. So how much cheaper? So if you're looking at that, we're comparing the answers. So we want to know the difference. So we take the bigger number and subtract the smaller number. So 80 minus 57, get 23, and that's £23. Now for question D, they're asking us to round 57. Now that was part of the question above in question 9. Round 57 to the nearest 10. So what tens is 57 close to or in between? Well, the nearest 10 before it would be 50. And the 10 after 50 would be 60. So if we think, well, what would halfway be? Halfway between 50 and 60, or halfway between 0 and 10 would be 5. So halfway between 50 and 60 would be 55. So if we've got 57, that's going to be in this half over here. So it's going to be closest to 60. You might like to think, oh, well, if the number is 5 or more, we round up, so that would go up to 60. But I think doing a diagram like this is nice to be able to visualise, well, how do I know it's closer to 60? What am I using as my midway or halfway point? And then I can see which side I am. And part B, use the rounded number to check your answer to question 9. Well, if you remember in question 9, we had 80 minus 57. But if we're using our rounded answer, what we're saying is 80 minus 60. And we're going to use our calculator for this, but hopefully you can see that because it's a rounded number, we don't really need to use the calculator because we're just looking at tens. So it's like 8 tens minus 6 tens, 2 tens. So we get an answer of 20. And that's approximately equal to, or it's close to 23. So that looks okay. Nice and close. Okay, question 11. Windows are sold in different widths. Marius chooses the window with the smallest width. Which window does Marius choose? So if it's the smallest width, it means the smallest number. Now we've got decimals here. But what we can do is we can start off by looking at the whole number part. So if we want the smallest one, well, we can say these numbers either start with a 0, or a 1, or a 2. Well, which is the smaller of those? Well, 0 is smaller than 1 and 2. So let's forget about all the ones starting with a 2 and the one starting with a 1. Because the 0 point something must be smaller. So we've got either 0.9 or 0.6. Well, 6 is smaller than 9. Says that one there. Question 12. Marius has a piece of wood of length 40 centimetres. We've got a diagram here and it says to be cut off. So we're trying to chop this bit off. Marius cuts off 1/4 of the length of the piece of wood. What is the length of the piece of wood Marius cuts off? We've got some choices here, but I'm not going to look at the choices for now. I'm just going to try and work out the answer and see if it's one of the ones available. So if he's cutting off 1/4, we want to know what a quarter of 40 is. So we want a quarter of 40. And the way we can work out a quarter of 40 is by saying 40 divided into 4 pieces. Okay? Or 40 divided by 4. Which we can do with our calculator. And we get an answer of 10. Now let's have a look if 10 is one of our options. 2, 4, 10. There it is. Question 13. Marius needs to measure some liquid. Marius pours liquid into a bottle. Okay, and we've got a measurement. We can see it's coming up to here with liquid. Marius needs 140 millilitres of the liquid in total. Okay, so that's going to be up here he needs. How much more liquid does Marius need to pour into the bottle to the nearest division? Use, oh, you can't see this bit. Use the correct unit. Right, so it says to the nearest division. So let's see, what this is closest, which marking is it closer to? Well, it's closest to this one, which is 80. Okay. How much more do you need to get from 80 to 140? Well, that's the same as saying what's the difference between 140 and 80, which would be take the biggest number, 140, and subtract the smallest one. Which gives us 60. And what units are we working in? Well, it's millilitres. So 60 millilitres. Question 14. Marius needs to drill a hole in a wall. We've got a diagram of a wall here. We've got one window here on the left, another window on the right. This is our wall, and we've got A, B, C and D. These are positions for the hole. We're also told that each of these, in other words, each of these measurements is 10 centimetres. The hole needs to be more than 30 centimetres from each of the windows. In which position does Marius need to drill the hole? 30 centimetres. If each square is 10 centimetres, well, 30 centimetres is going to be how many squares? Well, 10, 20, 30. So it's going to be 3 squares. So let's start from this window over here and go 3 squares across. 1, 2, 3. In fact, I'm going to draw a line. So we don't want anything that's within 3 squares, which would be 30 centimetres. So we can't use A. Now, we also need to be 30 centimetres away from this window over here. And that was 3 squares. So we go 1, 2, 3. So we can't have anything over this side, because these would be within 30 centimetres. So we can't have B, we can't have D. So the only one that's left is C, which we can tick down there. Question 15. Marius chooses a garage door for a customer. The customer wants an electric door, and the door needs to be more than 2.1 metres in height. So electric and more than 2.1 metres. Which door does Marius choose? So we've got 6 here. Now we've got the height, and we've also got whether it's electric or manual. We need the customer wants an electric door. So manual door, no good. Doesn't matter how high it is, it needs to be electric, so that's no good. This is manual, that one's no good, and another manual one. So rule 3 out. It needs to be more than 2.1 metres. 2.0, well that's less than 2.1, so that's no good. 2.2, that is more than 2.1. So it looks like that one, but let's just check this one. Electric door height, 2.1. We need it to be more than 2.1. This is 2.1, so that one's no good. So it must be this one here. And finally, question 16. The table shows the different building jobs Marius has done. So he's done 28 jobs on walls, 12 jobs on roofs, 22 jobs on fences, and 34 jobs on windows. Show the number of window jobs on the chart. So we've already got wall, roof and fence put on. Windows needs to be 34. Right, and I'm going to write that on here so I don't forget. So 34 we need for windows. Now, we're going to find where the top of the bar should be. So it's going to be 5, 10, 15, 20, 25, 30, 31, 32, 33. So that's going to be 34 there. But we need our bar to be over windows, which is over here. So I'm going to do an approximate little bar there. Now we don't have to be too precise. If we just want to then draw our lines down, we can. What I'm going to do is I'm actually going to kind of have a look at this. What's this? It's sort of 1, 2. So it's 1 centimetre and 2 millimetres, or 12 millimetres. So let's measure this. So 1, 2, so it would be to there. You don't have to make your bar absolutely exact, but we want it to be roughly the same width as these other bars. Okay, and we don't have to colour it in, but if you want to do a little bit of shading, that's absolutely fine. I'd probably just leave it plain, but I've done it on here so you can see it a bit more clearly. So that's the end of the paper. Hope you found it helpful. Please like the video, subscribe to the channel, turn your notifications on so you find out when I add more videos, and I look forward to seeing you again soon. Thank you.